So I want to introduce to you the work I have done on the ground-based and spaceborne lightning observations during CHUVA. This is in addition to what we heard right now. This is a perfect introduction to my talk, which already has been explained in Rachel's talk or just in the previous talks on the proxy data. So I've provided the LINET system from DLR on behalf of EUMETSAT because we are interested also for the proxy data generation for the lightning imager for the MTG, the Meteosat third generation satellite. So we will have in the next few years 2 new geostationary systems observing lightning from space from Meteosat third generation from 2018 onwards. And of course earlier already those are GLM system in 2015 or so and later. So there's a perfect alignment here or coincidence over Brazil where both satellites see the same area. LIS is our reference instrument. So LIS is observing at about 400 kilometers height, looking downwards to ground, operating more or less a digital camera, a CCD array, and that is what produces the events. Each pixel is called event, and if you group the events together, you get a so-called groups, and if you group the groups together, you get a flash. So that is just for explaining some of the terminology which is used in the following. We have made already some measurements, comparison with the LINET system and LIS in tropical experiments. This is an example here from Africa, an African shoreline. And we found already some results that there was generally good agreement between the LIS groups, the timing of the optical pulses, and the strokes observed from LINET. And that is also a result we got here confirmed in CHUVA, but CHUVA added a component, an important component, that the network was of very short baseline, so we could compare the details, much more details than before. So what we see here from the different systems is in VHF, the very fine scale structure of the flash. For instance, here from the cloud phase of a CG, a cloud to ground flash, or an intra-cloud flash here. From the VLF, LF, like LINET, we see larger currents in larger scale segments of the flash, and all these can produce optical pulses which propagate out of the cloud boundaries, and we mainly look from the top on the so this picture we have timing, and most of the sites were on rooftops, like here or here, some also on the ground. So these were the 22 or so cases we have observed, which with coincidence with LIS. We had about 5 or so golden days with high priority. We have seen already one example. Jeff has shown already the 10th of February, sorry, here. I show you also some examples from this day. And I go now through a series of images showing a comparison. Here we have the 27th of March, 2012. This is the bore line, north-south over the city. These data in green is from LMA, is the LMA sources, and in red is VNet stokes, and we see here latitude-longitude plot, and here the height against longitude, the height against latitude here. So we see generally good coincidence of the LINET and LMA structures. Of course, LMA sees much more sources than we see with LINET. And this is also indicated here, the blue squares. These, in this case, these are the flashes here. Yeah. Okay. So this is a radar scan from 10 February. And we think that it might be caused by a parallax problem, where this uses just a standard procedure for that, and probably we have to adjust it for our region here, where we have taller clouds than normally assumed in that procedure. Again, you see the same thing here. I've added only in this picture the least events and the least groups, so you see much more of these blue-colored. This is X-fold 7 February, a more isolated cell, just to study this type of convection. Same thing here with lighting data. Again, this is a much better coincidence for all systems. An animation of a few examples of single flashes. Here again, latitude, longitude, height, longitude, height, latitude, and the top panel is height and time. So the time of this flash, you'll see here, is about 0.8 seconds. And the green again is LMA. The red dots here, plus means positive, and the circles are negative, VNet and stokes. And this is the blue dots here on top, and the size of the dots corresponds to the brightness or to the radiance. So the flash develops at about 7 kilometers. It goes now up and down, so in the bi-level propagation mode. We have already VNet sources here. It's the same altitudes. So this is what we find here from CHUVA. The coincidence is rather good. And we have here, when the LMA sources go down, closer to the ground, we have a ground flash here, a ground stroke, another one here, and here again. Then a small gap here, nothing happening, and flash continues. Here again, a VNet source, and lower level intracloud flash. This is again only a summary of that what we have seen right now. And this is again the radiance plotted against the time of this flash. You see again this bi-level structure. And interesting now is when you see here more clearly, when this sees optical emissions in the first part of the flash, and the second part is missed more or less by this, and I think that this is caused by this lower level emission height. We have a lot of precipitation on top of that, and that we see in several examples. Also in this one, the difference here that the flash starts much higher up, at about 9 kilometers. We have both VNet and LMA sources. Again, a bi-level structure more or less, but much more higher up. It is more or less all signals are coincident with the main core here of the convective cell in that case. Yeah, again, in the later stages, we show you the principle, how it works. Lower level structure you see also here from satellite. Next thing is we are interested in, well, in somehow simulating the magnitude of our proxy data. So we are looking at radiance against the peak currents from VNet and against power from LMA, source power. And generally we find much scatter in the data, but there is some indication of correlation. At least here in this part of the plot you can see an increasing radiance with increasing peak currents. This peak is also coincident with that peak here. So one could think of using the power to simulate in a statistical way also the radiance for the proxy data. Last point is we are interested in the timing of these signals, what happens first or what happens at the same time. And I looked for the coincident events from different systems, and you see here a plot of the difference in time, in the number of observations. And if you compare two systems, it should be ideally at 0 if they are coincident. And we find a good coincidence for LIS and LINET. For LMA, we find that it's a little bit earlier in time. So there's obviously somehow a preparation or a breakdown, which we see here in this LMA, followed then by LIS and LINET at the same time, more or less. The main pulse, which we observe from ground-based system, and the optical pulse are more or less at the same time. And I must indicate here, as already in one of Jeff's slides, it was indicated that we have to be careful with the timing here for LIS. We have to do some corrections with some leap seconds, and we have to take care for the propagation time from the cloud to the satellite. We have to do some correction, and then we find this nearly perfect agreement here. Yeah, so few words at the end, how we simulate the proxy data. I used more or less the timing from LINET, and depending on the sensitivity of our network, I have to introduce additional optical groups like this using statistical methods, distributions. In this case, for about 100 kilometer baseline, it was 7 or so additional strokes, which we had not seen with LINET. In the CHUVA case, it's at least it is 1-to-1 really. And then, yeah, that you should see here. That is the outcome from CHUVA. This is a plot of the number of groups per stroke and the peak current here. So these yellow or orange dots, they indicate the CHUVA results. So we have about 1 or so, at least we have values smaller than 1 even. When we are very, very sensitive, and we see more with LINET than we see with LIS. And but at the normal threshold, we can say that it's about 1-to-1 this relation. And for larger scale networks like here, which we had done before, from other experiments, we find much higher values. So, thank you very much. That's what I wanted to introduce here.
Question.
Simulation, and but I think one could simulate it with log normal distributions and just then introduce random number generator for producing the data based on linear slopes.
Okay, and so you do have, with a positive correlation, you do have weaker optical with when you get down to these 1 kiloamp levels in Linnet.
Yes.
Did you make any correction on the radiance, or did you use whatever was on the
No, just the numbers.
Okay, so we might need to talk to Bill Koschek, because he says that that we cannot use that without several corrections that he has in mind. So.
Oh, you mean from the LMA or from this?
No, from LIS.
From LIS.
LIS.
Okay. But LMA has similar problems, I think, with the power source.
Harmard, very nice results. I was curious about the curve you have shown, the power of LMA with the radiance of a LIS, how that they resemble very well. So that means that can we use the power of LMA sources as radiance?
That was just a weak correlation, I think. So it was also the best case I found. So the others do not look so good.
And the other thing is that, could you comment on because I remember from Linnet that you have the sources, but you're making kind of like classification of intercloud and cloud to ground. So did you find any difference?
Yeah, I've also done this before. And the difference are not so large as you would expect, because obviously also a ground flash has a large part of it inside the cloud. There's the whole channel is illuminated. You don't find what you expect. So you find more or less that's the reason why I have considered that all flashes is more or less equal. Not categorized for the proxy data.
So it's kind of hard to hear, but were you talking about the time difference with the LMA?
Yes. Yeah.
Okay. Yeah, I was just going to point out, if you haven't removed the noise on the LMA, then your time differences, a lot of those noise things will turn up as timing differences. It wouldn't be correct.
Yes, that would be fair.